Today we are going to be looking at story problems. Don't check out just because I said the word story problem. I know that you've had a difficult time probably before in your life with story problems, but the trigonometry story problems are really not too bad. So let's take a look at it and then you can decide if you can handle these story problems, but at least listen and take your notes. Okay? So there's two pieces of vocabulary that we need to know first of all. One is called the angle of depression and one is called the angle of elevation. Okay, the angle of depression, it's the angle that's parallel to the horizontal. So this, in our picture that we have right below it, this is our horizontal, and these two are going to be parallel. So this is parallel with this. Remember, that's how we signify that they're parallel. So it's parallel to the horizontal going down towards the object. So this is our angle that's created going down to the object. So here I am looking from the hot air balloon down towards the object of money, and that creates your angle of depression. Okay? The angle of elevation is going the opposite direction. So like if somebody's on the ground and I'm looking up towards something. So it's the angle that's parallel to the horizontal, so here, and then going up towards the object. So here's the angle that's created for the angle of elevation. Okay, those are two pieces of information that you need to know in order to do the story problems. Okay, so the first one that we have is to look at a tree. Suppose a tree 50 feet high. So I'm just going to draw. I'm not really spectacular at drawing it. I can't remember if we've discussed this, but it is not my strong point for sure. So this is 50 feet high. Okay, so here's my tree. It casts a shadow. I'm not even going to attempt to make a shadow of a tree. We're just going to call it the shadow. Okay, and the shadow is 60 feet. Oops, I kind of went up. I didn't mean to. Okay, what is the angle of elevation from the end of the shadow? So here's the end of the shadow to the top of the tree. Here's the top of the tree. So this angle right here is the angle of elevation, which is what we're trying to find. Okay, so now I've created the picture. It wasn't too hard. I labeled how high the tree was. I labeled how long the shadow was. We know the shadow's on the ground. We know a tree grows straight up and down. Notice that the tree and the ground are going to make a 90-degree angle. So now I have a triangle. So it's already labeled. So now it's just like what we've already done before. So this is the hypotenuse. This is the adjacent. And this is opposite from our angle of elevation. So I have the information of the opposite, because we have 50 feet, and I have the adjacent with the 60 feet. So I'm going to set up the tangent, because tangent's with opposite over adjacent. So the tangent of x is opposite, which is 50, over adjacent, which is 60. Okay, so now I can reduce this and say that this is the tangent of x equals 5/6. You can leave it like this. Because of the fact we're going to use the calculator, I don't need you to show that you reduced it. You are welcome to reduce it. I don't need that shown as a step. Okay, so in your calculator, you're either going to do the inverse tangent of 50 divided by 60 or the inverse tangent of 5 divided by 6. So, or second tangent. Remember that you want to hit second tangent when you're looking for the angle. So I do second tangent of 50 divided by 60. Now, like I said, you could put 5/6 as well. I get 39.81. So the angle of elevation is 39.81 degrees. Okay, let's take a look at the next one. Not so bad so far. The top of a lighthouse. My drawings of lighthouses are so bad that I am just going to draw a straight line straight up and then call it the lighthouse, like that. Okay, so the angle of depression of a boat. So here's our boat. And here's our water. Here's the lighthouse. The angle of depression to a boat is 27 degrees. So here I am at the top of the lighthouse, right? I'm looking down, because the angle of depression goes down, towards the angle of the boat. So this creates 27 degrees. This is our angle of depression. Okay? Find the distance from the boat to the bottom of the lighthouse. So from the boat to the bottom of the lighthouse. So this is what I want to find. I got distracted telling you about my lack of lighthouse drawing skills, that we forgot to mention that it's 210 feet high. So I'm going to label this as 210. Okay. So now there's two different triangles you could look at. I could look at this top triangle right here, or I could look at this triangle right here. Remember that these two lines are actually parallel. right? The ocean line and the horizontal that you're looking out before you go down to the boat, okay? So if these lines are parallel, this creates a transversal, so this angle is 27 degrees because these are alternate interior angles, okay? Now, the other thing that we can say, this creates a rectangle because this is a right angle, this is a right angle, this is a right angle, and this is a right angle. So 4 right angles create a rectangle. Well, we do know from our study of polygons that rectangles, the opposite sides are congruent. So that means that this x is the same thing as this distance up here, which should make sense to you, right? You've got a rectangle, this distance from here to here is the same as this distance. Right? So now I could look at either triangle and get the pieces of information that I want. I could look at this triangle and call this one x with my angle depression of 27. And since the two sides are equal, this is the same height as the lighthouse from the top of the horizontal to the boat. Okay? So it doesn't matter which way you solve. I could use the bottom triangle, say this is 210, this is x, and this angle is 27. Either way that you set it up, you're going to end up with the same problem. So if I label the top triangle from here, this is the opposite, this is the adjacent, this is the hypotenuse. If I label the bottom triangle, this is where my 90 degree is. So this is the hypotenuse. Notice the hypotenuse is the same in either. This is the opposite, and this is the adjacent. Notice both the adjacents are x's, and both the opposites are 210. So it doesn't matter which part of the rectangle you use as your triangle. So since we have the opposite and the adjacent, I'm going to use tangent. So the tangent of 27 degrees is the opposite, which is 210 feet, over the adjacent, which is x. Notice the variable is in the denominator. Okay? So I have to multiply both sides by x to get the denominator on top so that the x is in the top so that we can solve for it. So I have x tangent 27 equals 210. Well, to get the x by itself, I have to divide by the tangent of 27, which we came across these when we were looking for a missing side a couple days back. So I have x equals 210 divided by tangent of 27. So in your calculator, I have 210 divided by tangent of, I forgot the angle already, 27. Okay, so I hit enter and I get 412.15. So our x is 412.15. Notice that we were in feet. So this is 412 feet. Okay. In the previous problem, we were looking for an angle, so I only put a degree sign next to it. In this one, we were looking for a side, so I had to make sure that I had labeled it accordingly. Okay. So let's take a look at the next one. A plane is taking off from Reagan National Airport for Aruba, rises at a 14-degree angle, so pretty small. 14 degrees. Okay. So here is our plane. It's about as good as you're going to get. My plane drawings. Okay, at a 14-degree angle with the ground. So rather than saying the angle of elevation, it described it as an angle with the ground, which is also acceptable. Find how many feet the plane is above sea level. So we're assuming that Reagan National Airport is at sea level. So this is at sea level. So if I want to know how high above sea level, that's straight up and down. So I want this one. When it has traveled a horizontal distance of 1,000 feet. So this is what the plane has traveled, but it's only traveled horizontally this much. This is the actual horizontal and vertical distance that it's going simultaneously. So the 1,000 feet is this bottom one right here. So if I wanted to describe this, I would say the plane has traveled, like 1,500 feet, or the plane has traveled 2 miles, okay? So now I label according to the angle of 14. Well, this is opposite. This is the hypotenuse because it's across from the 90-degree angle, and this is adjacent. So I have the opposite and the adjacent, so I'm going to use the tangent again. So the tangent of 14 degrees is opposite, which I don't know, over adjacent, which I do know, which is 1,000. So I times both sides by 1,000. So I have 1,000 tangent 14 equals x. So 1,000 tangent 14. So I get 249, oops, x equals 249.33. And remember that we were talking about 1,000 feet, so this is also in feet. So it's barely off of takeoff. Or, yeah, because it's only 249 feet high. So the way to do story problems is you set up the picture, draw your picture, somehow label, you know, where the plane is, where the lighthouse is, where the boat is. Then you label it according to where the 90-degree angle is for the hypotenuse, and then which angle you have, you know, with the opposite and the adjacent. And then it's like the problems that we've previously done. This is Square Rooter signing off.